Alright, so today we are going to talk about these statistics concepts, these basic concepts of mean and median. If there is, depending upon how the time plays out, if there is time, I can also talk about a third related concept called mode, but I don't want to commit to it right now because it might make the video too long. So let's focus on mean and median for now, and let's see how to calculate these. So before we proceed, let's conceptually understand what these things are, and then we can talk about how to calculate them for this specific example. So mean or average is, as we understand intuitively, you are given a bunch of numbers, so their average is the sum of the numbers divided by the number of numbers. So that is, for example, you are given heights of people or heights of students in a class. You add all the heights and you divide by the number of students, and that is the mean. Or you are given incomes of people in a city. You add all those incomes and divide that by the number of people in the city, and that is the mean, or that is the average. Median is slightly more advanced, or slightly a more abstract concept, I should say, that it is talking about the 50th percentile, or it is talking about the person who is bisecting the population in some sense. That suppose there are 100 people, let's take a slightly different example. Let's say there are 101 people, not 100 but 101. The reason will become clear in a second. And then the 51st person in a sorted order, the middle person has 50 people below him and 50 people above him, and that 51st person, whatever his number, his height or his income or whatever other characteristic that we are trying to calculate stats on, is called the median. And this is usually somewhat more robust. This is useful as a means of understanding the statistics of the population, because it is robust to outliers. So suppose I want to calculate the average wealth of people who live in a certain city, and let's say Bill Gates is one of the people who lives in that city, and I happen not to account for his immense wealth, then my average will be extremely wrong if I accidentally miss one person. Or by just including Bill Gates, the number is going to be skewed upwards so massively that it does not represent the population really. So the median person is going to have a reasonable amount of wealth that can be thought of as representative of the population. Or same thing with any other kind of similar stats, that is subject to outliers, that somebody has an extremely high amount of wealth or extremely high amount of influence on the stat should not skew the representative stat. So that's why people use median. It's more robust in that sense. And there is a similar concept of mode, but we'll talk about it. So let's go about this particular example here. So first, what do we have here? Numbers are, this is a simpler example, 2 3 4 5 6. So the average here is so mean, also called average, will be equal to 2 plus 3 plus 4 plus 5 plus 6 divided by number of numbers, which is 5, which is 2 plus 3 is 5 plus 4 is 9 plus 5 is 14 plus 6 is 20 divided by 5, which is 4. Or another alternative way of obtaining the same number is to note that 4 is, so this is a simple arithmetic progression, so 4 is the middle number, and that will be the mean. And median, so let's sort these numbers. We don't need to sort these numbers, I'm just doing it for simplicity. So the numbers are 2 3, they are already in a sorted order, rather 5 and 6, and I take the middle number. So there are two numbers here and there are two numbers here, that's the middle number. And note that the actual values of these numbers will not matter. So suppose this I change the number slightly. Let's suppose I make it minus 1, 1.5, 4, 55 and 10,000. I have changed two numbers on the left and two numbers on the right, but kept the relative ordering same. The median is still 4. So that's the beauty, or that's the robustness of the median. So suppose this 10,000 is Bill Gates in our example. If I were to just take the mean, it will skew the stats so massively that it will not represent the numbers. But the median represents the number still. It's more robust. So okay, that's about mean and median in this example. Let's take the second example. So 1 4 7 9 11 4, and I think this can help us understand median in a slightly better context. 1 4 7 9 11 4. Let me write this down. Right, so now in this example we have an even number of numbers. So the middle number is not really well defined. There is third number and fourth number, and which of these do you take as the median? And unfortunately there is no consensus in the community regarding this, in the mathematical community. So I have seen 3 definitions and all 3 are used depending upon the context. One is take the average of the two numbers in the middle. So sometimes people do that. Sometimes people take the left of the smaller of the two numbers in the center, and sometimes people represent both numbers. That is, the median is a tuple. It's a number on the left and number on the right. Let's go over this example. So mean, let's first calculate the mean, because that is straightforward. It does not depend upon this particular nuance. So mean will be 1 plus 4 plus 7 plus 9 plus 11 plus 4 divided by 6, which is 1 plus 4 is 5 plus 7 is 12 plus 9 21 32 36. Okay, it happened to be I did not choose the numbers this way, it just happened to be an integer. This is 6. So this mean is 6. Let's talk about median. So let's sort these numbers. 1 4 4 7 9 11. Now there is no center number here. There are two numbers in the middle here. There are two numbers to their left and two numbers to their right. So which one do I take as the median? So there are 3 choices, as I mentioned. So median, choice 1 is 4 plus 7 divided by 2, which will be 5.5. Sometimes people use this. Choice 2 is the left median, or the smaller of the two median. If they are equal, then that's the median, but the smaller of the two medians, which in this case will be 4. This is the smaller of the two medians. And choice 3, you report both numbers, 4, 7. This is think of it as a vector valued function or a vector valued result. This tuple is the median. All these 3 are, as I mentioned, there is no consensus about these. I have seen this second choice being used a lot, but first and third are also used. So it depends upon what exactly the questioner has in mind. It's not obvious from the choice here. The second choice is the safest. People use it. I've seen it being used everywhere. One good advantage of second choice is that it is, so that's the beauty of the median. The second choice is guaranteed to be a number from the given input. If you take the first choice, then it is not a number from the given input. You are taking the average, but that average may not be present in the input. This 5.5, this number is not present in the given array. So that's not ideal sometimes. And the third one, again, it's 4, 7, but we expect the median to be a number usually and not two numbers. So then it's not obvious how to convert these two numbers into one number. So second choice, I like the second choice personally. If there is a median, I'll always take the smaller of the two numbers, but depends upon the context. Okay, let's look at the third one now. 60551629. 60551629. These are the numbers. Okay, let's calculate mean. 6 plus 0 plus 5 plus 5 plus 1 plus 6 plus 2 plus 9 divided by 8, which is 6 plus 5 is 11 plus 5 16 plus 1 17 23 25 9 34 34 divided by 8, which is 4.25. And median, again, let's sort these numbers. So 0 1 2 took 0 1 2 5 5 6 6 9. So in this case we lucked out, the two numbers in the center are identical. So all the three choices that I mentioned in the above example, they are all going to give the number 3, except for the third one, which trivially gives a tuple of two identical numbers. But the third number and the fourth, the fourth number and the fifth number are identical, so it is going to be 5. So median here is unambiguously 5. That's about it.